Good evening, everybody. Thank you for joining in and being part of this evening. I am Rahul Soni. On behalf of TCS, I welcome you all to this webinar where we will talk about free masterclass on open source tools for malware analysis. In today's digital world, cyber threats are everywhere. Hackers use harmful software known as malware to steal data, disrupt systems, and cause serious damage to individuals and businesses. This is why cybersecurity has become one of the most important and in-demand fields. But how do experts detect and stop these attacks? That's where malware analysis comes in. In this masterclass, our esteemed expert will introduce you to open source tools for malware analysis, powerful free tools used by cybersecurity professionals to study and understand how malware works. Whether you are new to cybersecurity or looking to develop hands-on skills, this session will give you practical knowledge that can help you build a strong foundation in this exciting and growing field. So now, Dr. Vasan sir, before we dive deeper into this exciting masterclass, could you briefly explain what open source tools for malware analysis are and why they are essential in today's cybersecurity landscape? Also, since we have a diverse audience from both IT and non-IT backgrounds, so can you please share if this field is only for IT professionals or can non-IT professionals also build a career in it?
Yeah, so Mr. Rahul, thank you for the introduction and welcome all the participants to this master class on malware analysis. So the question is like, what is the application of malware analysis and whether it is useful for non-IT people or IT people? So my point is, irrespective of whether you are from an IT background or from a non-IT background, so as I was saying, like irrespective of whether you are from the IT or from a non-IT background, so the knowledge of malware is very important because in today's world we deal with a lot of things. We get a lot of online applications. We get a lot of softwares that we download from the internet, and we are not sure whether those tools or whether those software that we are going to use are actually a normal software program or whether they have some kind of a malware activities built into them. So it's always a good thing that if you are aware of some of the tools that you can use to analyze those software or those applications that you have downloaded from the internet before actually running or installing them in a system. So if you are aware of some of the basic tools, basic open source tools, you can do the preliminary analysis yourself. So that will help you to that will help prevent a lot of cybersecurity related incidents, because what we have seen is people actually most of them have Android phones, so they download something from the Android Play Store, or maybe one of their friend has sent them some APK files. So they are not sure whether what that APK file is actually doing. So maybe that APK file is doing some kind of a gaming activity, but at the back end it might do some malicious activity. It might be a backdoor program which steals some confidential or some private information from your phone. So in this particular masterclass, what we are going to do is we are going to see some of the basic open source software tools that one can use. So these are some openly available software tools. So most of the contents in today's session will be based on hands-on session. So I'll show you the tools as well. So these are open source tools, meaning you can directly download them and use them yourself. So I'm hopeful that by the end of this particular session, the audience will have a good understanding of this particular tools, and they can utilize themselves these tools to verify whether the binaries or the applications that they are going to install in a device or on their computers are actually normal program or whether they have some kind of malicious activities built into them. Thank you.
Yeah, thank you, sir, for your insight explanation. It clarifies that open source tools for malware analysis play a crucial role in identifying and mitigating cyber threats, especially with the evolving complexity of attacks. So, without further ado, let's dive deeper into the incredible masterclass. I will again hand it over to you, sir, because I think all students are eagerly waiting for this masterclass.
Okay, so let me share the screen.
Sure.
So as pointed out by Mr. Rahul, I'll be talking about some of the tools that one can use to perform malware analysis. So this will be the outline of the presentation. So basically, when we talk about cybersecurity or cyber attacks can happen in one of the two ways. It can either be carried out using this some kind of network-based cyber attacks, or it can be carried out using some kind of a malware or a malicious software program. So in this particular talk, we are not going to focus about the network-based cyber attacks. So there are a lot of cyber attacks which happens or which uses this kind of attack vector, but that is not what we are going to talk in today's presentation. We are specifically going to be focused on the cyber attacks which are carried out using malicious software or a malware program. So how do we analyze those kind of a malware programs or a malicious software? So I have listed out some of the tools that we can use to analyze those malware programs. So for example, this PUB strings and map. So these are some of the tools that we are going to see in today's session. And we'll also see how we can use each of this tool to analyze the application program to verify whether the applications or the executable binary that you're working actually is a normal program or a malicious program. So I don't think I have time to go through all of this. So I'll directly go to the malware. So the definition of malware. So what is a malware? So malware basically is a short form for a malicious software, which refers to any program or a file that's intentionally designed to harm a computer network, server, or a user. So basically malware are some kind of a application program, just like a normal program, but they are designed with a malicious intent. So once these malware programs are installed on the device can either be a mobile phone, it can be a computer, or it can be any device which is connected over the internet. So once this malicious software are installed on the devices, they perform certain malicious activity, which are the activities, those activities are malicious activities which are intentionally designed to harm your systems or your network or the server. So this is some of the type of the malware programs that are commonly known. So we have viruses, we have ransomware, scareware, spyware, Trojan, adware. So these are some of the well-known malware programs. So I'll not be discussing about each of this malware files or malware programs right now, but viruses, we know that these are the bugs which are normally attached to the emails. Then we have ransomware. So ransomware-based cyber attacks have been occurring more frequently of late, wherein the attacker encrypts the data on the victim's computer, and in order to decrypt or in order to get back the original file, the attacker will demand some kind of a ransom, and that ransom has to be paid in terms of bitcoins. And they will use a threatening tone that if the ransom is not paid within a given stipulated period of time, the files will remain encrypted and it might not be decrypted for the use anymore. So this the ransomware attack, which has been extensively happening in recent times. And then we have other kind of malware programs like Trojan. So Trojan is basically a kind of a backdoor program. It's a malware program which, when installed on a device, will allow the remote attacker to gain full control of your system. So once the Trojan-based malware are installed on the devices, the remote attacker has complete control over the device. He or she, the attacker, can take all the information that is available on the victim's machine, and those information can then be used for various nefarious activities. So let me directly go to this part. So basically, this is going to be the main point of today's presentation. So we are trying to analyze a malware program. So malware is basically kind of a software program, just like your normal software program. It's also a program, but it has some malicious intention, or it has a malicious characteristics built into them. So how do we analyze this kind of software programs, and how do we differentiate between the normal application program and a malicious malware program? So there are three ways to do it. So one is the static malware analysis. So in the static malware analysis, what we do is we observe the characteristics, or we observe the attributes of the malware programs, and then based on our observation of those static features or of the static attributes, we make some kind of a conclusion that the particular program is a malware program or whether it is a normal program. And then we also have something called dynamic malware analysis. So in the dynamic malware analysis, instead of simply statically analyzing the malware based on its characteristics, we actually run the malware program on a closed sandbox environment. We observe the running characteristics or the running behavior, or what are the characteristics that the executable executes when it is allowed to run on the sandbox environment. We observe those characteristics, we observe its runtime behavior, and based on our observation of its runtime behavior, we then make a conclusion whether a particular program is a malware program or whether it is a normal program. And then we also have something called a hybrid malware analysis, which is a combination of the static and dynamic analysis based method. So we'll start with the static based analysis techniques. So in the static analysis technique is based on just the normal static attributes of the application program that we are analyzing. So there are a lot of static methods that one can use to perform static malware analysis. So I hope the audio is clear to everyone.
Yes, sir. Audio is clear.
Yeah. Okay.
Audio is
Okay. So these are some of the techniques, static malware analysis technique I have listed out here. So this is by no means an exhaustive list, but these are some of the well-known techniques. In fact, well-known static malware analysis technique that are out there, and this can be carried out using the open source tools. So the first technique is something called the hashing. Hashing is basically so I've listed other techniques also: hashing, strings, Yara rules, and then something called peer viewer, and then finally we'll wind up with an online tool called a virus portal. So I'll start with the first technique, which is called the hashing. So hashing, as we know, if the audiences are from the IT background, you might know that a hash is basically a function which takes some input and it performs some algorithmic operation on those input, and then it generates some output. For example, in this particular figure, you can see we have a hash function, which is actually a kind of a program, and it takes an input. The input can either be a plain text, it can be a video file, it can be an image, it can be any input. So it takes an input, does some processing, and then generates a corresponding hash value. So basically, the hash value is kind of a signature for this particular input file. And we know that the signature is unique for each entity. So similarly, in the same line, what we can conclude is the hash value for a given input will be unique. So if you have two plain text and if they match with 99% contents in those two plain text messages are matching, even in that case, the hash value that this particular hash function is going to generate will be completely different. So even if you just change one or two characters in a particular file, the hash value that is going to be generated by the hashing algorithm will be completely different. So how the hashing algorithms will allow us to determine whether a particular program is a malware program or not is, what we will do is we will supply our application program, the program that we want to verify whether it is a malware or a normal program, to a hashing function or the hash algorithm, and then generate its corresponding hash value. So for most of the well-known malware program, there are centralized monitoring entity who have already done this particular process. They passed the well-known malware programs through a well-known hash algorithms and generate the corresponding hash value. So now you have the hash value corresponding to all the well-known malware programs. So in case if you now come across any particular binary file, and if you're not sure whether that particular binary file is actually a malware program or whether it is a normal program, what you can do is you can simply pass your binary file to this particular hash algorithm, generate its corresponding hash value, and then use that particular hash value, go to the dictionary that is stored, which stores the hash value of all the well-known malware programs, and if there is a match, so you can be sure that whatever binary that you're working with is actually a malware program. So basically, this is kind of a database operation wherein the database contains all the hash values of all the majorly well-known malware programs. And in case when you get a binary file and when you generate the hash value for that corresponding binary program, you can correlate that hash value with the hash value that are stored in the database. And if it matches, then you can be sure that the binary that you are trying to analyze is actually a malware program. So I have shown a list out here. So these are some of the well-known hash algorithms. So we have MD5, we have CRC, SHA. And for example, I've also shown out here. So I have an exe file called sol.exe, solution.exe. So now I'm not sure whether this particular executable is a malware program or not. So what I can do is I can simply pass this particular executable as an input to this hash algorithm. So the hash algorithm that I'm using right here is this MD5. So MD5 is one of the hashing algorithm. So it generates this particular hash value. So MD5 is a hashing algorithm which generates a 64-bit hash value. So depending upon what kind of hashing algorithm you use, the hash value produced will have different length. For example, for the MD5, the hash value produced will be of 64-bit. So similarly, if you use SHA can produce both 128-bit as well as 256-bit hash value. So let me show you this with an example so that it becomes more clear to you. So I hope this terminal is visible to everyone. Can you confirm?
Yes, sir.
So this is the PowerShell, Windows PowerShell that we work with. So here let me go to. Yeah, so inside this, I have a lot of hashing algorithms. So I told you about this MD5 hash algorithm, and then I also have this SHA 64-bit as well as SHA 256-bit. So the SHA has multiple variants. It can generate hash value 64-bit hash value as well as 128-bit as well as 256-bit. So I will show you the hash value that is generated by this particular MD5 and the SHA 256. For example, I have this calc.exe program out here. So maybe I have downloaded this calc.exe is this exactly calculator program that we have. So this is the exe file corresponding to this calc.exe program. So maybe it might be the case that your laptop doesn't have this calc application. So you went to an internet, downloaded this calc.exe. But since now you have downloaded this from the internet, you are not sure whether this calc.exe is actually a binary file which the Microsoft has provided, or whether it is a malicious program which someone has put over the internet. And if you use this malicious, or if you install this malicious calc.exe program in your laptop or in your system, you might fall victim to some kind of a cyber attack. So you're not sure. So what I will do is I will generate the hash value corresponding to this calc.exe program. So I will use the MD5. So you can see it generates this particular hash value. So this is a 64-bit hash value for this particular calc.exe program. So similarly, if I want to generate a 256 SHA hash value, I can generate. So you can see this particular hash value which you are generating using this SHA 256 is bigger compared to this one. So this is actually a 256-bit hash value, but the earlier MD5 it generates only a 64-bit hash value. So now you have, since when you have this hash value, what you can do is you can simply go online and then check whether this hash value that you have generated actually matches with one of the hash value of the malware programs that are already stored in some central databases. So this is exactly what I was talking about. So anytime you download something from an internet, so for example, if you are working with a Raspberry Pi model, so Raspberry Pi is something kind of a mini computer. So it has its own operating system. So if you're downloading that particular operating system, which is kind of an application program from the internet, and if you're not sure whether it is genuine or not, so they will have this hash value out here. So this is the hash value corresponding to the Raspberry Pi OS. And if you're downloading that from some third party, you can correlate this hash value. If the hash value exactly matches, then you are sure, or you can be confident that this is actually the genuine Raspberry Pi OS that I'm going to use. If this doesn't match, then obviously some kind of alteration of some kind of a modification has been done on that particular Raspberry Pi OS, and it might lead to some kind of a cyber attack. So similarly, if you visit some other site, anytime you download something, you might have noticed they will provide this hash value. It can be either a MD5 hash value, something like this, or it can be a SHA-256 hash value. So this is how the hash value will allow you to identify a normal program or a normal application program from a malicious software program. Okay, so the next particular tool that I'm going to talk about is something called the strings. So basically, so when you are provided with an executable file, if you double click it, if it will simply run, it will start executing. So what I'm interested, or what you might be interested, is to see what kind of strings. So when I say strings means words or sentences which are present within that particular file. So I want to maybe visualize, or I want to know what are the strings present within a particular binary executable file. So if you simply double click that particular executable file, something like in window, it will start running. It will not show you the exe file. But what my end objective is, I want to see what are the strings and what are the words and what are the sentences which are present within that particular binary file. Because based on those information, maybe I can make some kind of an assumption, or maybe I can make some kind of inference based on the strings which are present, strings or words present within that executable, whether that particular file is normal or malicious. For example, if I have this particular bp6.ex, this is a binary executable file. So if I want to see what are the strings and what are the words present within this particular executable file, I can use this particular tool called strings, which displays all the strings which are present within this particular exe file. So it will, how the strings work is, it will list all those words which has a character length of 3 or greater. So it will list all those words which has character length of 3 words or more. So you can see some of the words are not doesn't have any meaningful interpretation. For example, this VP3, VW3. So this might not be of any use to us. But you can also see some strings are something like this: 99.124.22.1. So this is definitely some kind of an IP address. And similarly, you can see there are other string, something like get layout, gdi32.dll. So if you know DLL are basically kind of an application or support application which the exe program will use to for performing successful execution. So anytime you have an exe file, there is a corresponding DLL file. So how this will help you to make the analysis, how this will help you to verify whether this bp6.exe is actually a malware program or a normal program. So based on this particular set of strings that we have listed out here, we can safely say that this particular file is going to perform some kind of a networking based activity. So obviously, if this bp6.exe is an application program which was not supposed to do any kind of networking based activity, and when you run the strings and you saw an IP address present within that particular exe file, so obviously this means that this particular program or this particular executable has some kind of a backdoor program installed in it, which after the installation on the victim machine is going to connect to the remote attacker machine. So maybe this particular IP address is the IP address of the attacker machine. So it does the reverse connection. So it establishes a connection with the attacker machine. You don't have to do anything. The malware itself will initiate the connection with the remote attacker machine. It will establish the connection, and once that connection is established, the attacker gets a full control of the system, and he can do as a wish with their computers or with the data. So this is how the string programs will allow you to perform the analysis. So basically, the endpoint is like, if you're not expecting some kind of strings within the particular exe file, and when you ran the strings on that particular exe file and you got to see all this kind of string files which should not have been present within the exe file, then you can make a safe assumption that this particular version of a exe file is doing some kind of a malicious activity. So let me again show you this with an example. So I hope this PowerShell is visible.
Yes, it's visible, sir.
Yeah. So again, let us take an example of this calc.exe program. So I want to see what are the executable, what are the strings and what are the words which are present within this calc.exe program. So what I can do is I can simply run this program on this calc.exe. So if I do that, it will list all the strings which are present within that calc.exe program. So since this is a full-fledged application, it will have a lot of strings present within it. So it will take some time. Yeah, so you can see, since this is a Microsoft application, you expect a lot of Microsoft-based words out here. So you can see these are all the strings which are present within this particular file, right? So if this was some kind of a malicious program, if this version of the calc.exe was modified to perform some kind of a backdoor program or backdoor attack, obviously you would expect to find some IP addresses as part of the string. So I hope this helps in determining the properties and the characteristics of the application program. So similarly, there is this lab304.exe. This is actually a mild malware program, which is actually kind of a Trojan program. So if I run this same string program on this one, it will also again list out what are the strings present within this particular exe file. So obviously, since this is a Trojan-based program, Trojan is basically kind of a backdoor program, there will be some kind of IP addresses. Okay, so the two techniques that I have discussed up to this particular point, they only work when when the malware program is not packed. So what do I mean when I say that a particular program or a particular application is packed? So by packing, it means something like a compression, just like how you compress your file using WinRAR and WinZip, right? So similarly, you can pack your executable to make them smaller. So there is this tool called UPX, which allows you to pack your executable or compress your executable. So if the malware program or if the author of the malware program has packed his particular malware application using this particular tool, then the two techniques that we have discussed just now, the strings and the hash, they will not work. Because if you try to run the hash on the packed version of the malware program, it will generate a different hash value. And similarly, if you try to run a string on the packed version of the malware program, it will not list the entire strings which are present within the malware program. It will only list some of the strings. So the two techniques that we have discussed earlier will only work if the malware is not packed or if it is in its original form. But what the author of the malware will usually do is, in order to avoid detection by this kind of a tool, they will pack or they will compress their malware program so that it becomes difficult for the analyzer, or it becomes difficult for the cybersecurity analyst to analyze the file. So this is one tool. This is actually an open source tool which can be used to pack the malware program. So let me show you this with an example once again. So again, we'll be working with this calc.exe program. So now I want to see whether this particular calc.exe has been packed using UPX or not. So the way I do that is by just checking. So I'm just checking using this particular tool called UPX, whether it has been packed using UPX or not. So this is the command that I need to provide. So you can see that it says that it is not packed. It has not been packed. So obviously it is not packed using the UPX. So I can pack this using this command. I just need to change the parameter out here. So instead of -t, I will just remove this one. Now it has been packed. So earlier, if you see the size of that particular file, I think the size of the calc.exe before it was packed was 91,000, I think 9,18,528 bytes. So now if I try to see the size, you can see it has been compressed. It is now 3,94,240 bytes. And if I now test this, it will show that it has been packed using UPX. I can, if I get to know that it has been packed using UPS, I can unpack it using this particular command, which will simply unpack this version. And then if I do ls now, you can see it has been unpacked and it has been restored to its original size. So this is the reason I showed you this particular tool is because this is an open source tool. It is not a proprietary tool, and it is freely available tool. And this is one of the most prominent uh, this is one of the most prominent packing tools that the attacker usually use. So in case if an attacker is a novice attacker who is starting the cyber, is new to the cyber domain, he will definitely be using this particular tool to compress his malware program, because there are other tools to compress the malware programs, but those are proprietary tools for which the attacker or the author might have to make a payment. But since this is an open source tool, most of the attacker uses this particular tool to pack their malware programs. So now you know how, if you come across a particular program which has been packed using UPX, how to unpack it, and then once you have unpacked it, you can use the strings or the hash function to generate the corresponding hash value or to list out the strings present within that particular binary application, and then do the analysis as we have discussed earlier to make the reasonable assumption whether the program or the binary executable that you are analyzing is a normal program or a malicious program. So this is what I explained it. So there is this packing algorithm, which is a UPX tool, which will pack your file. And if you want to analyze it, you have to unpack it first. So do I have more time? Because I think we already exceeded half an hour limit. So do I need to continue or?
We have 5 minutes now, sir. We can
Okay.
spare 5 minutes.
Okay. Because there are a lot of things to show because we are short of time. So I thought.
Yeah, yeah.
So, okay. So let me quickly tell you about this tool called Yara. So this is another tool which you can use to perform some kind of a pattern matching based analysis. So basically, Yara is a pattern matching Swiss knife for malware analysis. So basically, what Yara does is it maintains a signature of most of the well-known malicious program. So basically, it's kind of an antivirus. So the antivirus also have a lot of rules. So those rules might be written in some other languages, but Yara is one of the way. Yara is a tool which allows you to write a signature to identify the malware program. So let us see how Yara allows you to do that. So this is the syntax of the Yara rule. So you have this keyword called Yara rule, and then the name of the rule that you want to use, and then we have something called metadata. So basically, this metadata contains the description of the malware program or the application program for which you are going to write the signature, and then we have this strings. So these strings are actually the strings that we are trying to see whether they are present within that exe file or not. So earlier we have seen that using strings, we can list out all the strings which are present in the exe file. And similarly, so we have the strings out here. So what we are trying to do is we are trying to write a Yara rule which looks out for this strings, whether these strings are present in the binary executable that you are analyzing or not. So if those strings are present, then the rule is going to fire, and then you can be safe that this particular version of the software application contains this strings. Okay, so the final thing is this condition. So in condition we can have a or b. That means if either this string or this string is present, it will fire. And also we can have an and out here. So if it is an and, then both the strings have to be present in order for this particular rule to fire. So let me show you an example. So earlier we have seen two examples wherein I showed you a sample of a malicious program. So what I'm trying to do is now I'm trying to write a Yara rule. So this particular Yara rule will fire if these two strings are present within that particular exe file. So I'm trying to look for this particular URL within the exe file as well as this particular string. So this is actually a hexadecimal representation of the string. So anything placed within this quotes represents the hexadecimal representation of the string. So what I'm trying to do is I'm trying to verify whether a given exe file has this particular URL as part of a string, and this particular string, this particular hexadecimal string as a part of its string. So the condition here is end out here. So it will only fire if both of these rules are both of the strings are present within that particular file. So let me show you this with an example. So if I go to this particular example out here, so you can see this 4D 5A. So this is hexadecimal representation. So in case if you're not familiar with hexadecimal representation, so in the realms of computers or in the realms of cybersecurity, there are a lot of ways to represent the strings. So this happens to be the one of the way to represent the string, and there are other ways in which you can represent the same thing. The hexadecimal representation is there, base 64 encoding scheme is there. There are a lot of encoding scheme. So basically, this is the hexadecimal representation. So let me show you this with an example. So this is my hex editor. So in this hex editor, I will open this particular file. So as I said earlier, I have this malware program. So this is my malware program. So if I open this on the hex editor, you can see that the first two numbers are 4D5A, and this is exactly what is mentioned out here, 4D and 5A. So this 4D and 5A is actually a representation of our MZ. So whenever you're working with exe based, so Windows based executable program, so it has a specific file format which is called the portable executable file format. And that particular portable executable file format will always have these two letters at the beginning, MZ. So this MZ is actually an acronym for the author of this uh, particular file format. So it's an acronym for the authors. So any P file will have these two letters at the beginning. So M is actually 4D. So 4D is the hexadecimal representation of this capital M, and this 5A is the hexadecimal representation of Z. And that is what we are trying to look in this particular rule out here. So basically what we are trying to say is we are only going to fire this particular rule if it happens to be a portable executable based file, and within that particular executable file we have this particular strings out here. So let me run this and show you. I have out here. So basically what I'm trying to do now is I have this lab0304.exe. I'm using a Yara rule. So my rule is present within this tral.yara. So this is exactly this rule, this particular rule that I was talking about. And in that particular rule, what I'm saying is I want to verify that this particular exe is a portable executable based file. And if it is portable executable file, it should also contain this particular URL. So if I run this out here, you can see it will match this. So obviously this particular string is present within this particular exe file, and since it is also since it is a exe based application, it will always have this 4D 5A hexadecimal representation, which is MZ. So this is how you can write a Yara rule to detect malware programs, because obviously writing a malware program is not that an easy task. So what the author of the malware will do is they will try to reuse the same code over and over again with small modification. So now if you know of any cyber attacker group, a well-known cyber attacker group, you will get to know about their pattern as well. So once you know about their pattern, you can write a corresponding Yara rules to detect their signature, so that in case if you come across a malware program which have been authored by those groups, then you have a corresponding Yara rule which you can use to detect whether that particular application is a malicious program or not. So the last thing I want to show you is we also have this rule for packed UPX. So earlier we saw an example wherein we say that strings and hash can only work with unpacked version of the exe file. So in case if you want to write a Yara rule to determine whether it is packed or not, one way to do is to use the tool UPX tool itself. The other way is to write a rule itself out here. So this particular rule says that if it is packed using a UPX, it will detect that. So obviously we are looking for this MZ string once again, and then hexadecimal representation of UPX0 and UPX1. So the rules is basically says that if MZ occurs at the 0th position of the file and UPX0 or UPX1 occurs in the first 1024 byte of that particular malware program, then obviously this particular rule is going to fire, and then you'll get to know that this particular binary file has been compressed or it has been packed using a UPX tool. So with this, I will stop here because I think we are running short of time. So I will stop the sharing.
Yeah, sure, sir. Sure. So thank you so much for this incredible session, sir. With perfect examples in your overall presentation really helped to understand the concept better. And I hope all participants have not missed this opportunity to note down the key points from the hands-on masterclass session delivered by sir. So I can see there are a lot of questions from the participants as well in the chat box. So audience, we will surely be addressing your questions shortly. But now moving on to the next part of the session, I will take only 5 minutes. I would like to walk you through the details of our certificate program and share all the important information you need to know. I think I would request my AV team to share the slide. Okay, thank you. So, as a part of our commitment to bringing you the best career opportunities, we are thrilled to present an exceptional program launched in collaboration with the prestigious IIT Roper and TCS. This program is designed to help you break into the rapidly growing cybersecurity field, regardless of your background. Whether you are a fresh graduate or someone looking to switch careers, this course is tailor-made for you. IIT Roper's collaboration with TCS brings forward a cutting-edge program designed to make career cybersecurity learning practical, accessible, and industry-oriented. This program focuses on hands-on learning, industry case studies, and real-time insights. It allows you to specialize in areas like network security, vulnerability management, malware analysis, cryptography, and cyber forensics. We understand how important it is for you to secure a job in this competitive landscape. By enrolling in this program, you are not only just gaining knowledge, but you are positioning yourself for success in one of the most sought after fields today. So this is your opportunity to learn from the best and take your career to new heights. I think the registration link has already been posted in the chat box. You can access that link, and you can also scan the QR code, which already been shown in the slide. Also, we have a surprise for you. What if we say you can test your cybersecurity knowledge before registering, and that too absolutely free of cost? So we have got you covered with a free technology awareness test. The link has been posted in the chat box. You can directly click on that and register for the same. So now it's time to take the audience question. I think students are waiting for this Q&A part. So I would like to start with the first question. The Mugna Mandal is asking which tools should we learn which are relevant in the industry, and any certificate you want to suggest in that cybersecurity domain. Vasan sir, over to you.
If you are new to cybersecurity, I think this particular course, which is jointly offered by TCS and IT Roper, is actually a very good starting point. So obviously, we are also going to provide you with a certification, with a certificate at the end of the certification course. So this using the certification course, you can apply to various job roles and positions. And then once you have this certificate with you, and if you are looking to go deeper into the domain of cybersecurity, you can go for more professional cybersecurity courses. So I think all those details will be made clear as we go ahead deeper into the course. I think with that, I think I have answered the question.
Okay. Thank you, sir, for answering this. Afzal is asking, cyber crimes hashing plays an important role. So while cross-checking the hash files, if the hash files were replaced, what are the consequences?
So obviously, when we talk about the hash files and their hash values, so these hash values are basically kind of maintained in a centralized database. So obviously, those database itself have to be those database themselves have to be protected from being changed or from being manipulated. So that one has to take care of. So in case if that is the case wherein the hashes that have been stored on the database cannot be manipulated, then there is no way of like verifying or no way of changing that hash value. So in case if you have a binary file, you can run it through hash algorithm, and then whatever algorithm you get, you just correlate that with what is stored in the database, and if there is a match, you can simply make a conclusion that it is a malware program. So that is how it works.
Thank you, sir. So Niladri Viswas wants to know about the Yara method, which you have explained in the standard procedure. So what is the extension of that string file?
So it can be any file, it can be any executable file. So I have shown all the example based on uh, .exe file, which is the executable program file that you have for Windows operating system. So similarly, if you go for I think Linux based operating system, you have executable by the extension .elf, and similarly for Mac OS, you have a different variant of Mac program. So Yara rule is very generic. It is not specific to uh, Windows-based operating system. You just have to change the signature. For example, I showed you that all the binary executable for the Windows-based operating system will have that 4A5D. MZ. So similarly, there might be some kind of a unique pattern corresponding to executables from Linux and from Macintosh. So maybe you can extract those unique characteristics of those of the executable from those operating system to design your own Yara rules. So Yara rules is very flexible in that sense. So basically, most of the rules I think that you have for the antivirus are also written using the Yara as well. So Yara is one of the predominant tool which is extensively used to write signature patterns to detect malware programs.
Hope Niladri got his answer. Okay. So Harshal Paints is asking, sir, can attackers use base 64 to evade detection?
Right. So actually, I wanted to show you one of that particular technique, but since we didn't have any much time, so I was not able to show you. But I intended to show you one particular program. So if I have some time, I can show you that particular as well. So do we have some time? That was a
Uh,
very interesting question. I want to
sure,
show
sir.
that base 64 encryption. Okay, so I think I will show you one example. Let me share the screen once again. One of the way we have discussed about the static technique, there is also something called the dynamic analysis. So in dynamic analysis, what we actually do is we run the malware program on a secured sandbox environment. So we need to run in a secured, isolated sandbox environment because malware programs are actually a malicious program. If you simply run them on the host computer, they might end up harming your computers or your system. So what is advisable is actually to always run the malware programs on a secured sandbox environment. So this particular tool called hybrid analysis is actually one of the sandbox environment, which is an online sandbox environment. So I hope this page is visible. Can you see it?
Yes, it's visible now.
Yeah. So what I want to show you is I want to show you this example wherein I have this particular malware program. It's actually called an emotet. This is a very well-known malware program, which is actually a kind of a Trojan based program. So how this particular emotet malware works is usually this emotet is actually sent using a phishing email wherein it has this embedded, it has this malware embedded on the mail itself, or there is a link which upon clicking will download this particular malware and install on this computer. So with this particular malware work is it has this PowerShell command built into it. So once you execute this particular emotet malware program, what it does is it runs it runs this PowerShell program, and in the PowerShell it will run the PowerShell command to download this malware program from a remote computer machine, and then it is installed on the device. So let me show you this with an example. So I have a sample of this particular malware program out here. So I will run this malware. So I have this is the malware, emotet malware that I was talking about. So if I run this on this particular program, it will take some time. It is not running. Okay, I have to do something. So since this is a sandbox environment, it provides me with a list of environment on which I want to run this. Whether I want to run in Windows 10, Windows 11, Windows 7. So let me go with the default one, Windows 10 64-bit, and I will generate a public report out here. So it has simply run and it has detected this to be a malicious report. But this is coming from your malware analysis. So basically this is an antivirus result. But what we want is we want to see the actual uh, runtime behavior of this particular program. So here you have the sandbox reports out here. So what the sandbox have done is they have actually run this particular malware program on a sandbox environment and then perform some kind of analysis. So if I click on this one, it shows me all those indicator of compromises. So since we don't have much time to go through all this, but these are all the indicator compromises based on which this particular application has been marked as a malware program. So if I go down at the bottom, what I will see is this. This is actually the command. This is the base 64 command that will actually be executed in the PowerShell, and this has a lot of commands. So now since this is encoded in a base 64, I don't know what this is actually doing. So if I simply copy this particular portion And then I will go to this tool called CyberChef. So basically, this is a particular website which helps you to translate between different encoding forms. So since I know that this is a base 64 encoding, so what I will do is I will so this is from base 64, and I know that I want to convert this one. So I need to do some more pre-processing. The null bytes. So now you can see you have the corresponding command out here. So this is actually the command that will be executed on your PowerShell. Now it makes a lot of sense out here. So maybe there are a lot of URLs, because if you remember, what this malware is doing is it has some URLs. It will visit that particular URL and download that malicious program from that URL. So let me go back to this particular program and then check whether are there any URLs there or not. So I also have a filter out here which I can use. Yeah. So now if I do that, you can see it visit all these websites, and this will definitely be a malicious URL. So if I copy this URL, and then if I want to check whether this URL is a normal URL or a malicious URL, I can go to this tool called virus total, and I can provide this URL out here. And if I run it, so you can see that it has detected this particular URL to be a malicious URL. So this is how you can do the analysis, right? So I hope that answers your questions.
Yeah, absolutely, sir. Thank you for a clear explanation. And meanwhile, the chat box is overflowing with questions as well. So Bhavne is asking, and I think this question is in everyone's mind: AI gonna impact on cybersecurity fields in terms of employment?
So just like any other field of technology field where the AI has penetrated. So for example, now you have Chat GPT, wherein you can get the source code for almost everything. So similar to Chat GPT, we have something called, let me show you this. There is this site called White Rabbit Neo dot. Again, so let me answer this particular question with an example. So I hope the screen is visible again.
Yeah, it's coming.
So I have this site called whiterabbit.new. So basically, this is kind of a chat GPT for your cyber security attacks. So in case if you want to design a cyber security payload, so something, so if you're familiar with Metasploit framework, there is a lot of attack payload that you can use. So what this particular tool does is this allows you to generate the corresponding code. So if I say create a Metasploit code for DOS attack, so what it will do is it will generate the corresponding code in real time. So now even a novice user who doesn't have much understanding about how all these things work can generate the corresponding attack payload and use this attack payloads to carry out various types of cyber attacks. So yes, to answer a particular question, so with the advent of AI, with the advent of machine learning, deep learning, NLP, cybersecurity has become more prevalent than before, because earlier to design a cybersecurity or a cyber attack payload, you need to have a specialized knowledge regarding how to design those kind of a payload. But now with this kind of a tool, with this kind of an online tool which allows you to generate the attack payload on a fly, everyone can generate this particular attack payload and then create some kind of do some kind of a social engineering and then deliver that attack payload to a victim machine and then carry out the cyber attack. So yes, to answer your question, cyber attack has now become more prevalent than before, and we should be taking care of, or we should be taking the cyber threats more seriously now than before.
Thank you, sir. Thank you for explaining with example. So with this, we have come to the end of the session. In case if you have any doubts or you want any clarity or any questions do you have, you can reach out to us at info.tcsinhub@tcs.com. I would like to especially thank Dr. Subha sir for coming here, and it's our pleasure to have you with us today. The way that you have explained and the way you have summarized everything, it's really awesome. And I would like to thank audience as well for their active participation. Thank you once again for your time and patience.
Thank
Thank
you.
you.
Thank you, sir.